we're going to do today is we're going to continue with our discussion about services, focusing on so-called started services, and we'll show some examples of various ways to program started services, and then I'll start a discussion about various communication mechanisms you can use to talk back and forth between different parts of a started service. So in order to do this, let's start by looking at a number of different examples. We're going to look at 3 different examples here, each of which will illustrate different dimensions of programming a so-called started service. We're going to look at one example that's kind of a music player example, very, very simple example, kind of expects the implementation to do certain things so that code doesn't block. Then we're going to look at a download service, which is actually not unlike what you're doing, a little different in some ways, but it's along the same lines of what you'll be doing for your next programming assignment, or at least a part of your next programming assignment. And that'll illustrate a few things. And then the final thing we're going to look at is a logging service, which will illustrate how to use the Android Intents service, or Intent service, which is a very cool service that lets you do certain things to work in the background. And we'll take a look at all these things. And later on, we'll come back after we've covered more of the IPC mechanisms, and I'll talk about all the patterns that underlie this stuff. There's a whole pile of patterns here. There's patterns like the command pattern. There are patterns here like the activator pattern. There are patterns like broker, proxy, and so on. And so we'll get a chance to cover that, and I'll look in the implementation details of Android in a bit more depth so you get a sense of how it works under the hood. OK, so as you might expect, implementing a service is very much like implementing an activity. There's certain things that you do. You start by extending the service, and then you have to go ahead and fill in a number of different hook methods. The hook methods are somewhat different from the ones we have for activities. No surprise there, because the lifecycle events are somewhat different. But nonetheless, that there's this notion of inheriting something and then overriding the various lifecycle methods. So lifecycle methods include things like onCreate, which looks similar to the one that you have for activities, the main difference being that you don't get this bundle passed in. And then there's also a couple other key lifecycle methods, probably the most important one being onStartCommand. And that's kind of the workhorse for a started service to get you into the service. We'll see that there's also some methods that are not used for started services, but that are used for bound services, this thing called onBind and onUnbind. Those things get used for bound services, but not for started services. You still need to provide a no-op implementation of onBind, however, that does nothing. And that can be used by the Android mechanisms, the Android infrastructure, to figure out whether something's a started service or a bound service, by whether onBind returns null. You also have to go ahead and add some entries into the Android manifest.xml file, and these are going to complement other stuff that's in there, like the activity descriptions and other kinds of components you can describe to add support for services. And there's a bunch of things you can do with services, and we'll talk more about that as well. There's a nice article that you can read about on the web by this guy named Lars Vogels, and he talks about a whole variety of different topics. He has an article that talks about how to implement services, and I recommend you take a look. There's some good stuff there that may help you. OK, so let's start taking a look at some different examples, starting off with the music player service. So the basic example of this service is to play music, and you give it a file, and when you push play, it goes ahead and starts playing. And even if you switch, even if you move to a different activity, the service will still continue to play whatever you asked it to play. And it's not actually till you come along and push the stop button when the thing stops playing. So we're going to talk about that one first. Very, very simple example of a started service. Nothing much going on there at all. And that has a lot to do with the way that the music player component or music player object is implemented on Android, so you don't have to do much of anything. OK, so let's first show the activity side of the world here. This is going to extend activity. And as you can see, it's got a play method and a stop method. We're going to assume that we have a XML file, a resource XML file that connects these methods to various buttons you can push, the play and stop buttons. And as you can see here, when you push play, then it goes ahead and creates this intent. So take a look here. There's the intent. And it says, I want to use the music service as the class that implements this service, this intent. And then we go ahead and we stick a song ID, which in this case is just a pointer to a resource that's connected to this. A real application, of course, would give you a menu from your playlist to choose. We're just hard coding this stuff in here to make it simple. And then after you've indicated which service you want to have played, then you go ahead and say start the service. Now notice in this particular case that we're adding in the song ID as something called an extra. An extra is basically some data that can be connected to the intent, and you can put it in there via some kind of key. In this case, it's called song ID. And later, when we want to retrieve this thing from the intent, we can use that same key in order to be able to get the extra. And you'll see there's a whole bunch of discussions about extras, various places. When you say start intent, it'll go ahead and start the service. We'll look at that in more detail later, and the magic happens at that point. When we're done playing things and we want to shut stuff down, then all we have to do is click on the stop button, and that will generate an intent that will say stop the service. And you go ahead and say stop service with that intent, and it'll go ahead and stop. OK, so that's the client side. Very, very simple. Although, again, in real life, you'd give people typically a set of music to choose from as a chooser or something like that. Let's now talk about the service side of the house here. So the service side is going to start by extending service. And then what it's going to do is when it's on start command, hook method gets called back. So as we'll see later when we look at this in more detail, when you call start service, that causes the service to get kicked off, and it will go ahead and call the on start command hook. And you then take the intent that came there. As you can see, the intent is passed in right here. You take that intent, and then you go ahead and you look up here, and you get back the appropriate song ID that corresponded to the data that was passed along with the original intent when you started the service. In other words, the thing that was back over here that we stuck into the intent. So now we can extract that thing, and then we use this to go ahead and create ourselves a music player that will play that content. So we're giving it a res ID. This thing is basically what's called a res ID, or a resource ID. And we use that to create the player. And then we go ahead and we say, start playing the song. Now, here's what's important to realize about this particular call. And this does not apply to services often. And this is because of the properties of a music player. When you call the start operation on a music player, then that doesn't actually block. The start call does not block. It returns right away, and then the music is queued up and it's played out on the audio player at that point. And we pass back a flag that says, don't restart this service if it shuts down in some unexpected way, if it gets killed because you're running out of memory or something like that. So don't restart it. We're going to have to click start again. We don't want it to replay. And then finally, after we've decided to shut this thing down, later when someone clicks the stop button, that's going to go ahead and cause the onDestroy method to get called as the service is going away, and will stop the player at that point. So that's how the player eventually gets stopped. So it doesn't stop on its own. We just go ahead and have it stop when the service is destroyed. If you want to learn more about the media player class, take a look at this URL, or this URL that describes the media player, and it's got a whole bunch of things you can do to play media and start and stop it, and it's very cool. OK. So here then is the manifest file for this stuff. As you can see, it has some things you may look familiar. Basically the activity part, we define an activity. We give it a name, music activity. We give it a label that we get from the resources strings file. And then we go ahead and set up a filter that says when someone wants to play this activity, this is how you launch it, and so on. And then down here, if you see, we say that the service is exported, which means that it can be accessed by anybody who has the right permissions to get access to this thing. It's not private to this particular application. And we give it a name, say music service. If you do not put this thing in here, then you'll have a hard time getting your program to run, because the client activity over here won't be able to see that the service is actually available for use via this means. So don't forget to put that in your services file. When you're first playing around with this stuff, it's easy to forget to do that. If you take a look, there's some descriptions here about service elements in Android, and these tell you all the different things you can do with a service. And we kind of talked about that in the past, and we'll talk about it some more. OK, so this is intended to be a very, very simple example of a started service. It just extends service, doesn't do much of anything really, and it relies on the fact that calling the start operation on a music player doesn't block to make it be so simple. You don't have to, in fact, this particular service actually runs in the main thread, or this runs in the main application thread. So there's no extra thread that's created anywhere. It just runs in the main thread, and because it doesn't block, there's no problem to have it run in the main thread. Services that do things that run for a longer period of time, like your stuff, downloading a file or doing something else like that, they typically can't get away with this because you wouldn't want to have them sit there and block the main thread for the duration of the long download. Okay, any questions about that? Very, very, very simple. First example, just to kind of get our feet wet. You'll also notice that there's no communication taking place between the service that was told to start and the activity. So maybe I should make that point too. Also, there's no communication from the service back to the activity that invoked it. So that obviously is a very simple-minded thing, and a real application might need something more sophisticated, as we're going to see shortly. Okay, so let's take a look at another example service. So this is a service that's a bit more like what you're doing. This is a download service, so the idea is that you throw up some kind of user interface and you give the user the ability to type in a path name, or sorry, a URL, and then the activity takes that URL. It's going to, in our particular case, it's going to start a service that's going to run in the background in a separate thread, because you don't want to block the main thread while we're downloading the content. And then it'll go ahead and download the content, and when it's done, it's going to store it someplace, and it's going to then send back some information to the client indicating where it put the file. So then the client can go ahead and actually read that file and display it on the display somewhere. So that's basically the idea here. Okay, so this is a bit more sophisticated. Let's kind of step through all the various things involved here, and you'll get a chance to learn a little bit more about how these things work under the hood. So it starts out by having the client send an intent via a call to start service. So you can see here we say start service, and we go ahead and send an intent over. And that then causes the download service to be activated on demand if it's not already running. If it's already running, then it'll get delivered to it. If it's not already running, then it'll start it first. And this is based on something called the activator pattern. We're not going to talk about the activator pattern at the moment in any detail, except just to note that the activator pattern allows you to start applications or processes or services or whatnot on demand so that you don't end up using resources unless something is actually being accessed. So the idea there is to optimize the system resources so you don't take up memory or processor time or disk space or whatever if you're not actually using the thing that's involved. The download service then is going to do a bunch of things. It's going to just have a thread that's going to run in the background, and it's going to be something called a service handler, and you'll get the chance to see a bit more about how all this works as we get through this in more detail. And that service handler thread is then going to wait for intents to be queued, and then it's going to go ahead and pull the intents off the queue one at a time, as long as there's intents on the queue. And then it's going to go ahead and dispatch a method called download image in the context of this background thread, this thread that's running in the background. And you see that there's all kinds of different variations on a theme in this space. This particular example is very simple. There's more cool examples we'll look at later. This particular way of doing things implements something called the command processor pattern, which we will look in more detail at as a pattern later. But for now, it's basically a way for a client to send work to a command processor. You send a command to a command processor, and the command processor can queue up the commands, and then it has one or more threads that run in a pool in the background, and it pulls work off the queue and runs them without blocking the caller. In some sense, you can think of command processor as sort of a stripped down version of active object that we talked about before. Yes, sir?
So in this example, where would download image, like where would the code for download image exist?
We're going to look at the code for it, but the code for download image is actually going to be part of this intermediate class, this helper class called service handler. And you'll get a chance to see how that works. It's really cool. It's a what I'm going to be showing you here is an idiom that appears all over the place in Android. And so you'll get a chance to see lots of different realizations, some that we code ourselves, some that are built into some of the pieces of Android. So here's the basic pieces of this solution. We have download activity, which extends activity. When someone clicks on this thing to download the file, an intent is created, much like what we did before. And in this particular case, we're going to take whatever URL was passed in by the user in the edit text, and then the widget, and then we're going to extract that, and we're going to create a URI, which is basically, let's see, I guess I should actually say, I think it's URI, parse, which is going to go ahead and create a URI from this thing, and then it's going to set that as data for the intent. So we'll see that there's a bunch of different ways to do things with the intent. All intents have this thing called data, and you can set the data. In this case, we're setting the data to be the URI that the person wants to have downloaded. And so we add that as the data, and then, God, actually got to check that. I think it may be actually URL. Yeah, it's URI. I'll double check that. In fact, what the heck? Let's go double check that right now so we don't get confused. Yep, I was right before. It's URI. It's got a method called parse somewhere. Yep, there it is. So URI parse is going to take a string and turn it into this so-called URI, Uniform Resource Indicator. OK. And then we go ahead and say start service, give it the intent. Patrick?
Why wouldn't you do the set data on the first example? So if you're only doing one, do set data.
Just to show different things. So you could do set data there too. Yeah. No particular reason. So then we go ahead and launch the service that handles the intent, which of course will be the download service. We're not going to show the code for downloading the file since that's what you're writing for your assignment, and but you probably have a pretty good idea what it's going to look like. So here is a piece of how this works. I'm going to explain this part first, talking about the activity/client sending a request over to the download service, and we're going to focus on that flow of communication. And then next, we're going to talk about the flow that comes back from the service back to the activity. So here's how this works. Now, what I'm about to show you is very idiomatic. You see this all over the place in Android. So we have a download service, which extends service. And then in this particular case, we create ourselves something called looper, which is called mService looper. And we then define ourselves an instance of something called a service handler, which we define here as a nested class. And service handler, as you see, is going to do some things. So service handler is actually going to extend handler. And so by extending handler, that means it's going to get access to a message loop. And we'll see how this gets used in a second. The service handler constructor goes ahead and takes the constructor parameter for the looper and makes that its looper. We'll see more how that works in a second. And then it's got a handle message method, which is what's going to get called back when we're going to pass it work to do. And as you can see here, what it does is it's going to take the message that's passed. This answers Nolan's question from before. And it's going to go ahead and take the message, and then it's going to crack open this thing, get the intent out of the message. You'll see how the intent gets in the message in a second. And then it's going to call download image. And download image is going to do stuff. And we'll talk about that later. And then when we're all done, we say stop yourself. And this is set up in a very special way to avoid pulling the rug out from under services that are actively running. It'll allow them to continue running. And when the final reference calls stop service, it'll go ahead and shut itself down. Here's the onCreate method. Keep in mind, onCreate gets called back when someone says start service. onCreate method gets called back. And as you can see, what this thing does is it goes ahead and it creates a new handler thread. A handler thread is something we looked at a couple lectures ago when we were talking about concurrency. And that allows you to run a thread in the background that has a looper and other kinds of things. So we say handler thread, please go ahead and start, so it becomes an active thread. We go and grab its looper, and we take that looper, and then we pass that looper into the constructor of the service handler. And I won't show you this code right now, but if you take a look at what happens here, it's really, really fascinating. What they do is the getLooper method actually returns to you a reference to the thread-specific storage object that corresponds to the looper running in the handler thread. So keep in mind, when we call start over here, that's going to kick a thread off in the background. It's going to be running in the background, and it's running its own looper in the background. And we just got ourselves a basically a handler to that guy's looper. And now we're going to use this in order to be able to pass work to that background thread. So let's take a look and see how that works. So when the onStart command gets called, remember, onStart command gets called after onCreate is finished, and it passes in the intent that was originally generated when the client called start service. So if we go back a couple things here, you see where you call start service right there. Pass an intent in, as you can see right there. And then, after the service gets launched via the activator pattern, after the onCreate method gets called to initialize it, which as you can see kicked off a handler thread running in the background, and then made this so-called service handler object that we created go ahead and have that as its looper. So that means that that service handler will now be processed in that background thread. Now when onStart command gets called, which is in the foreground thread, right? That's the foreground thread of the service. He goes ahead and he says, hey, service handler, I'd like a message. I'd like you to give me a message, please. Thank you very much. And he sticks his start ID, which comes in from part of onStart command parameter, and the intent that he was passed from the client. And he says, hey, service handler, I'm going to send you a message. Now, if you think back to our discussions about the active object pattern and so on, this goes ahead and takes this message and it sticks it on the queue of messages that correspond to that handler thread that's running in the background, which happens to be running the service handler as part of its looper process. And since we got the message from the service handler, when we send it the message, it's going to turn around and come back through the handle message call right here. So this handle message call now takes the intent that was sent to it, and it says, hey, download the image, please. And then that'll go ahead and download the image, and we'll talk about that code a little bit later. So basically what we're doing is we're transferring the control from the main thread, which is where the onStart command is invoked. We're getting a message. We're making a message from a service handler that's running in a background thread, and then we're sending that message to the background thread, and it shows up via the callback to handle message in a separate thread of control. This pattern appears all over the place in Android, and we'll see it again from another couple points of view shortly. Any questions about that? So what that means is now we can download the file in a background thread that will not affect the foreground thread. And then when we're all done and everything shuts down, we're going to quit the looper, which will cause everything to shut down, and that thread the thread resources will be reclaimed, and everything will get to go away nicely. Now, it's instructive to think about how you might take this basic design that I showed you here and modify it to work with a pool of threads as opposed to a single thread. The solution we have here only lets you do one thread of control. And it's more than instructive, it's actually necessary to do your next assignment. So your next assignment will require you to be able to have a pool of threads as opposed to just this particular way of doing things. You'll also be doing this particular way of doing things as well, but you're going to be using something called the intent service to do it, which shields you from these details. Okay, any questions about any of that? All right, so to analyze things, this particular way of doing stuff with a worker thread and a service handler is a very idiomatic solution. You see it all the time. It implements the command processor pattern, and you take a look, for example, in Android, in some of the MMS processing, you'll see service handlers. A lot of the apps that come with Android out of the box use this approach when they want to run services in the background to have a thread at a time. In fact, it's so common that Android actually provides a framework that does this stuff for you. And that framework is called the Intents framework. And so the next discussion here is going to be us taking a look at another example of a different service that is implemented using the Intents framework. So in this particular case, we're going to write a multi-threaded logging service. So you're familiar with the Android logging ability, you can have a call to a log operation to log messages, and normally you just call that in, and well, actually you don't really know how it gets implemented, but it does something. And if you take a careful look at your log cat, it'll show you the output of the logging, so it has a display. So we're going to come up with a multi-threaded logging service, not necessarily because multi-threading logging service is all that useful, just because I want to show you how to use the intent service, and so you'll get the basic hang of it. Your next assignment, you also get the fun of implementing an intent service-based version of your download service, which looks a bit like what we just showed you for our download service, except most of this work is done for you by the intents framework and the intent service. So the client is going to call a command which is expressed as an intent via intent service. So as you can see here, we're going to put an extra in. We're going to call it log message. We're just going to give it some message to log on the activity, and then that's going to get called back in the background in a separate thread inside the logging service. And as you can see here, the logging service extends or inherits from the intent service. So it overrides and fills in a method. And the method that it fills in is the onHandle intent method. That's the one you fill in to do the work. So it's very, very stylized, very canonicalized. Internally, Android's going to start a service handler with a handler thread, it's a worker thread, just like we looked at before a minute ago. It's going to keep track of the queue of intents that are coming in there. Every time a new piece of work comes in, Android will ensure that the onHandle intent method gets called on that intent in the background thread to do the processing. And if there are no more intents to handle, then the intent service knows how to shut itself down. So it doesn't stay running for very long. If there's no work for it, it's up as long as there's work. Once the work goes away, it goes away as well. So it doesn't stick around. That obviously would be something else you could program if you wanted to, but that's not what the intent service does. Okay, so let's take a look at how we might implement this code. We're going to have a background logging activity which extends the activity, and when you click on this thing to send it a log message, then it goes ahead and creates an intent, and it puts the extra onto this thing. I think I'm going to make this a little bit more concise. That's too verbose for my taste. Let's just say log message. That's the name of the message we want to log. That's the name of the extra. As Patrick had pointed out before, there's no particular reason that we couldn't use the setData method to do this, just using an extra for the heck of it. And then we launch the service who's going to handle the intent. Here's that service. This is implemented as an intent service subclass, so background logging service extends intent service. As you can see here, it's going to do very little in its onStart command method, with the exception being just saying, don't restart me if I crash unexpectedly. Let someone else start up another intent and I'll take it from there, which makes sense. And then the onHandle intent method, which I'm going to tweak a little bit to say log message. When the onHandle intent message gets called, it takes the intent that's passed in and it extracts out from it the extra that we passed in, which was the log message, turns it into a string, and then goes ahead and prints that string using the log cat mechanism, the logging API. Notice again, of course, the powerful inversion of control in the Android frameworks. You don't have to think about this stuff. It's doing callbacks. It's calling back onStart intent. It's calling back onHandle intent. It's calling back onCreate. All these things are just hooks that give you a chance to create stuff or to be able to manipulate things with queues or threads. Gives you a chance to process the requests that come back in a separate thread, etc. That's all hidden from you. You don't have to worry about how that works. A couple interesting things here. This particular example, just for fun, we're not going to export the logging service. So this thing is only usable within this particular application. No other applications can use this. May not be the best idea to do it that way, but just to illustrate, you can do that. And something else we're going to do is we're going to instruct Android to run the logging service as a background process. Again, maybe not the right thing to do from a performance and semantic point of view, but just to show how easy it is to run things in their own processes. Okay, so kind of analyze this stuff. The The logging service is also intentionally very simple. In fact, it's probably somewhat overkill to do this. You really don't even need to use a service for this thing. I'm just illustrating the mechanisms, not necessarily advocating using it for this. By the way, what would be the downside of using an intent service and the intent service framework in the context of something like logging? Why might that be overkill?
You incur the overhead of spawning a new process.
Right, so we're spawning a new process if we were to choose to configure it as a process. Even if we choose not to configure it as a process, but we run it as a background thread, there still is overhead in order to be able to communicate between the client, which is calling start service, and the logging service. So for something as short-lived as logging, which, knock on wood or crush your fingers, is not going to block, that's probably overkill. So, again, you have to think carefully. Is it worth running these things concurrently? Am I getting any win from this? Am I better off doing it some other way? So for things that don't block or don't take long to run, it's probably overkill to pay all the cost of concurrency and synchronization to do that. So you get to decide what's right and wrong. In general, you would use the intent service when you want to run a component, even when the user is not interacting with the app that hosts that service. So you'd use it as service or intent service when the user wants things to keep happening in the background even when they're not talking to things in the foreground. That was kind of the example I gave before. If we were switching around a lot, we wouldn't necessarily want the things to go away. So that's why you use a service in the first place. Okay, so programming with services, programming with intent service, very, very straightforward for a lot of these use cases. They can be overkill, but you get a lot of bang out of the box without a whole lot of extra work, which is pretty cool. Okay, any questions about that? So for your assignment, you're going to have to know how to do the intent service, and you're going to have to know how to do some other stuff we're about to talk about as well. I just want to see if there's any questions about that. Thing to do also is, like I said, think about how you would add thread pool. Because keep in mind, intent service doesn't have a thread pool. It has a single thread. And so if you want a pool of threads, you've got to do some other stuff. The hint is to use the thread pool executor that we talked about when we talked about the async task framework. So that's probably a good thing to do. Go back and review the lecture, watch the video when I went through the code and showed how thread pool executor works. That's the trick to doing a thread pool. It's pretty cool. Okay. By default, the service class uses the app's UI thread or main thread. So if you want something to run for a long time, then you need to somehow either spawn your own thread using this service handler pattern or use intent service, which does that for you. In fact, if you look at the intent service implementation, it looks pretty much like our download service, just a few other little tweaks and tricks, taking advantage of certain Java-isms to make it simpler to write the code. Okay. The other thing is, if you write a service by yourself, you have to figure out how to stop it. If you do the intent service, it knows how to stop itself. The problem, of course, maybe it stops itself a little prematurely from what you want. So there's pros and cons to using these frameworks. They may or may not provide you with the right semantics, so be aware of what they do. All right, next topic. So up to this point, we've talked about how to get communication from the activity over to the service, and that worked fine for logging, that worked fine for music playing, but for things like downloading files, that wasn't sufficient because you really want to get something back when you're done. You want to know, did it work, did it not work? If it worked, how do I get what got downloaded, right? So you have to find ways to do that. So what we're going to do now is we're going to talk about a very interesting inter-process communication mechanism in Android that is called the messenger. And we're going to talk here in this particular set of slides about using messengers for started services. But be aware that they're also perfectly acceptable for use with bound services. And there's a pile of examples of both in Android. Okay, so what's a messenger? Messenger is a really cool little abstraction that allows you to encapsulate a handler. Remember, handlers are things that can get called back. And then allow you to be able to take that messenger and send it across to another process, to a service or something else, such that whoever you're communicating with can use the messenger that they receive via whatever means they receive it by in order to be able to send messages back to the handler in the originating process. Right? So think about this. So you're going to start something in one process, you're going to create a handler, you want this to handle some kind of callback, and then you're going to make a messenger that encapsulates it, and then you're going to pass the messenger to another process, and then inside that process we're going to extract the messenger from however it got there, often through intents, for example. We're going to pull the messenger out of the intent, and then we're going to use that messenger to return to sender. And if you look really, really closely at the slide, you'll see a picture of the Elvis stamp with the label return to sender. And die-hard country music fans will know why it says that. And since you're in Nashville, you should know too. So once you call send, it's going to go ahead and send back the message back to the handler that was originally used when you created the messenger in the original sender process in the first place. Any questions about the basic idea here? You can use messengers with both bound services and started services. We're just going to focus on the started services right now. Later, after we've talked about the broker pattern and some other stuff, you'll see how things work. I should also point out, by the way, that all this stuff works because messengers are essentially proxies. And we'll talk more about the proxy pattern later. OK. So what I'm going to do now is I'm going to walk you through the steps that are involved in programming the download service that I showed you before, which is a little different from your download service, because your download service is going to end up using a couple other things. You'll use the intent framework and some other stuff, but it's along the same lines. I'm going to show you how you can use this in order to be able to create a messenger and then pass that messenger to the download service. And after the download service is done downloading the file that was requested, it'll then use that to send back the path name back to the client, so the client can go ahead and display the image that was in that path name. So that's the big picture here. And what I'm showing you now are just a bunch of steps involved in this thing. And what I would argue is that you could certainly go and read the documentation, you could look at the manual pages and the HTML documents, but it might be sort of hard to see how all the pieces fit together. So what I'm going to try to do is I'm going to try to show you sort of step by step what's going on. And keep in mind, under the hood, there's a pile of patterns here, like command processor and proxy and so on, that are simplifying this. And I'm just focusing on the key points in the interaction. So we start out with some kind of download activity, and that guy goes ahead and creates a reply handler, which is just a subclass, or it doesn't even have to be a subclass. It could be an anonymous interclass instance that has a handler as the base class. And then we go ahead and we create a message, and that message is going to hold a reference to the handler. So we create a handler, we create a message, we associate the handler with the message. So now the messenger now holds that particular reference to that particular handler. We then go ahead and we create an intent, and we associate the messenger with the intent. So we can stick it in the intent as an extra. So now it's kind of like those like Russian dolls, that nest, right? We've got a handler nested inside a messenger, which is connected inside or attaches an extra inside an intent. And then we can go ahead and we can say start service, passing the intent, which contains the messenger, which contains the handler. And that ends up doing various things. Let's say in this particular case, it's going to end up crossing a process boundary, and we're going to have a service activated if it's not already running. So the download service will be spawned to run as a process or a thread, but let's say it's a process, if it's not already up and running. That'll call the onCreate method, and then onStart command gets called. When onStart command gets called, now we're actually looking more at what we had showed before. So we're going to create a worker thread as a service handler, and we're going to go ahead and activate that thread or launch the thread so it's now running as a thread in the background. We then go ahead and we call send message, passing in the intent, which is now bundled inside of a message. So talk about nesting, right? We've got a handler inside a messenger, inside an intent. The intent comes over to the server. We now create a message and stick the intent inside there. There's lots of nesting going on here. And that'll end up eventually having this background thread have its handle message hook called back, which will then take the message that it got that was put there by send message. It'll crack it open, extract out the intent, crack that open, extract out the messenger, and then it'll go ahead and download the file, download the content, the image, put it in a file somewhere in the local file system, and then it will go ahead and return the path name to the sender, passing back the path name of the file that was created that stores the file. And that will again cross the process boundary. And finally, that messenger will then dispatch the handle message callback hook on the original handler, which is where you'll say, aha, I've downloaded the file, or it didn't succeed, depending on what happened. And if you downloaded it, then you can go ahead and get the file because you've got the path name, and then you can go ahead and display the image somehow. A lot of steps going on there, right? So the diagram here really helps to kind of break this down step by step. Now, obviously, when you program the code, it looks a little different. But these are all the steps that are taking place under the hood as this thing is running. Any questions about that? Good thing to sort of know how this works. We'll talk about a couple of other inter-process communications in our next classes, and you'll see that they are somewhat different from this stuff, but they have some of the same flavor, getting information across address boundaries, address-based boundaries, and doing it in a way where the data is shielded and it'll work in a special way across the address spaces. So here now is how you might actually program this particular beast. So we're going to have the download service, which is going to get the message using all the things we showed before. And now what I'm going to do is I'm going to kind of zoom in on the download image method, which, as you may recall from before, download image was part of the service handler in our download service. And I'm just showing you a little snippet of this. So somewhere in here is the code to actually download the file, which you guys already have some experience with from your last class. So we download the file, and when we're all done, we'll end up with a file that'll be stored on the file system somewhere, and we'll have a path name to this thing, because we will have created the file, so we can control what its name is. Now what we're going to do is we're going to do the following. We're going to go ahead and get ourselves a message, and we're going to stick back the result code. So result would mean succeeded, failed, whatever happened as a result of trying to download that content. And then we're going to create something called a bundle. And we're going to use this bundle so we can communicate across address spaces. And that's because these things may run in different processes. And then we're going to go ahead and set the path name string in this bundle to be whatever path name ended up being when we downloaded this stuff. And then we're going to set the data of the message to the bundle. And then we're going to go ahead and we're going to say, hey, intent, please look up the messenger extra that was given to you when the whole thing was created. And when this whole thing started, there was a messenger that would have been created on the activity side. And we kind of didn't show that code from before, but that code would have been on the activity side. And that would then have been used to pass with the original intent. And when it showed up on the receiver side, now we're going to crack it open, get back that messenger. And once we get the messenger, we're going to say, oops, probably need to say messenger, cast it back. We're now going to go ahead and get the messenger. We're going to say messenger.send. And that's going to take the message that we just created that includes the result and includes the other information that's important here, like the path name, and it's going to send that back to the receiver side. Yes, ma'am?
The messenger is the handler associated with the UI thread?
Yes. So
This message will get stuck in the UI thread sleeper and...
yes, the question is, where does the code actually get run when you're back on the client side? So here's the actual client code, a snippet of the client code. And so here's the download activity. As you can see, we make ourselves a handler here. And this handler is made in the main thread because there is only one thread on the client side at the moment. And this guy is going to go ahead and have a handle message method. And when send is called over on the service side, that's going to end up triggering handle message being called back on the client side in the UI thread. And as you can see here, what it does is it goes in and it gets the data as a bundle, and then it uses the data to get the path name back, and then it checks to see if things worked okay and you actually got a path name and so on. If it doesn't, it throws up a toast. If it gets everything back it expects, it goes ahead and calls display bitmap. And display bitmap is given a path name, and that'll go open the file and blast it out. And that'll take place, of course, in the UI thread. Now, of course, if you don't like to pass files back and forth, you could always use some of the stuff that Zach McCormick talked about the other day with Android shared memory. And you could put the file into shared memory, and then you could pass something back so the client could get the shared memory. That would be another way to do this. Lots of different techniques, same basic idea. But the key thing to note here is that what we're getting back here is coming back in the client's UI thread, and the handle message is giving us a message that came from the service in a separate process. We're extracting information from that and then using that to ultimately display the image. Any questions about that? So your code will have some sort of flavor of this for some of the things that you're going to be implementing. So to kind of summarize this thing, messengers provide a flexible framework for communication between processes on Android. They're very, very flexible. In other words, you can pass messengers around from activities to services and services to activities and services to services and activities to activities and all kinds of things in between. And they can send and handle message to their heart's content. The problem is, if you're not doing simple stuff, like I think this is a pretty simple example because you're sending over a URL and you're getting back the path name, that's pretty simple. If you start having services or handlers with lots of methods, this gets really unwieldy in a hurry because you've got to pack all this stuff in and you have to keep track of what's an extra and what the meaning is and so on. So there's some other techniques we're going to talk about later using the Android Interface Definition Language, AIDL, and binders, which will give us more powerful ways of communicating back and forth. That's typically used, by the way, for so-called bound services. But you'll get a chance to see how that stuff works. And it's more strongly typed. It looks a bit more like real object-oriented programming. OK, so that is basically the discussion for today's lecture. What we're going to do next lecture that I give is we'll continue along talking about other IPC mechanisms like pending intents, like broadcast receivers and so on. And that'll give you all the information you need to do your assignment. But of course, keep working on the assignment. It's got a lot of pieces. There's lots more stuff in this one than the one before. So make sure that you are keeping up with that.